Great. So this is our logo, and we're named after the room that we're located in. So our office is, you might be in there, is in D120, which is the room in this building. Before the rest of the talk, I was asked to tell you about the ULB locker keys because there were groups in the ULB where the person leading you around didn't mention the locker keys. So even though you can't use the lockers in the underground section without an Athena card, you can get a key from the information point for the lockers upstairs. And you don't need your card for this. You can show your student identifier and should get a key for up to 4 weeks, and then you can use the lockers in the ULB. Continuing what the Fachschaft or the active students body is, well, there's something that we call the Fachschaft or the student body, which is all of us. All of you, all of us, which are all students at the computer science department. And a few of them, these people here, myself, and the people down in D120, we call ourselves the active students body because we do tasks like the Ophase, like many other tasks that I will get into. And then there's the student body council, which is more formally, they are elected once a year, and 9 of the computer science students are elected there each year. For example, from the organizers, Claudia is in the student body council, and Hannah and myself are active students and not in the council. These are all the active students from like a year ago. Many new faces are missing still, but we tend to be around 50 or something. There are different committees that we are in and that we try to manage and get people in. The first of all is the student body council I already mentioned. 9 students are elected there. Then there's the faculty council, which decides on different things, on professors, on changes in the teaching and more. And then there's the LUST, the teaching and student committee, where the people of us that are elected there, they decide with the department how the teaching changes. For example, when we introduced the new English masters, the LUST had the idea and they created the masters. Let me wait a second. Then we have Lena. Lena is another committee that is around money for teaching, where professors come and ask about, okay, I need money for sending my students to this conference or for reorganizing their teaching, or we want to do like a soldering workshop and want to get money for this, then we ask the Lena. And the last and also interesting point is appeal committees. Every time a new professor is added to the TU Darmstadt, they have to go through an appeal committee. And in there are professors and other status groups and TU students. And they decide with the professors who will be the new professor that gets decided by professors and by students as well. And that's a cool job to have. We also do different things like the GNOME. You might be in there where we play games, or we have like a Nikolaus party every year that we organize. We have a summer party every year that we organize as well, where many students come, have fun. We have a DJ, we sell drinks and stuff. We also have the Ophase, which will take place in 1.5 weeks from now, I think, where 80 students or so will be taken to the Starkenburg, which is a location in Heppenheim where we have 5 or 3 days, I think, of workshops and getting to know each other and so on. We also lend you stuff if you want to. We can lend you laptops. If you don't have one, you can get one from us. If you lost your laptop, if you can't afford one, we can lend you one each semester. And picnic blankets we just bought, and we can lend you many more stuff. Another project from the student body that I really like is the Klonforts. You might have seen it in the toilets. That's just like a newsletter in the toilets because there you are sitting or standing, having time, and can read stuff. where we try to publish interesting information. Another event that will take place on Friday is the faculty party. It takes place on Friday, not Thursday. Thursday is stated in your info letter, but that's wrong. We made a mistake. We had 22 iterations of this plan, roughly, but still this mistake slipped through. So it's on Friday at 23 or at 11 p.m. in the 806 QM. For all these things that I mentioned, the committees and the things we organize and the organization of the party, of the OFAT, of the Ophase, we need your help. Because, I mean, we are just students. Students leave, students come. And we really need people that are willing to invest some time to do these things, to organize the next Ophase, to help in the next Ophase, because all these people here, they don't get paid. We just use our regular time. And if you want to join us, each Wednesday at 6 p.m. in B002, we have our regular weekly meetings on d120.de/helfer. You can get more information, or you just visit us in d120. Or if you don't want to visit us, you can get some useful links on d120.de/links, where you can find our Discord, Mastodon, Instagram, and so forth, where we try to publish interesting information, where you can help us, what is new at the department, and much more. For today, we also have a work adventure, which is most interesting for the online participants. Today at 4:30 p.m., we will start a guided tour through the work adventure where one of us tries to play games with you and stuff. For the people in person here, we have other events like the Uni Rally. You can, of course, go to the work adventure as well, whatever fits you best. The bar tour. Yeah, the bar tour is there. That's correct. And that is the end of the presentation. Are there any questions? From online, for example. Questions? No? Yes. That's it. Was ist der nächste Punkt? Frage? Die Lightning Rounds später sind, or the question is about the Lightning Rounds later on at 3 p.m. These are free talks, 20 minutes each, short lightning talks, that's where the title comes from. And we have the TUTSAT, the Dart Racing group, so a student group trying to build a rocket and a satellite, another student group trying to build cars, racing cars, and Janus Blümel, which is a VMI from Hessian AI, who will talk about AI in general. So free talks, different topics, 20 minutes each. Sure thing. Any more questions? If not, then thank you.
Welcome again. So many people interested for stay abroad, potentially. Decent ratio of applicants to outgoing students, so fair chances, definitely. All right. And as you may already have gotten to know, I do have a few roles in this department. Exchange coordinator as well. So, what I'm going to do in this talk, it's just a slide overview again, because let's be honest, there are always several questions to be clarified in details afterwards anyways. So it's just an introductory talk on stays abroad, on studying abroad. I will provide a short overview of potential options for you, time frames, how the application process essentially works, and so on and so forth. If you have any questions, just raise your hands. I'll try to answer the questions during the talk. So, okay. The first thing, of course, always is there a good reason to stay abroad? Why should I stay abroad, right? Well, first of all, it improves your intercultural competencies. And that's also our baseline to send students abroad. For our department, at least, it's not about a specific number of credits, or that you actually can manage to study in the plan-to-be time or something like that, right? So whether you want to go for courses that can be completely transferred back to our degree doesn't play a role in the selection procedure. For us, it's just important that you want to go abroad and cover intercultural experiences. You will gain insight in other cultures, and you should know by now what a culture is, right? And also other university systems. And of course, just improving foreign language skills. All of that definitely helpful and nowadays really important from time to time for your CV. Plus, we have a very specific way of transferring credits in our department. As I introduced earlier, we have this mini module system. And that's also the reason why we decided to not transfer credits, either from other universities previously or stay abroad, onto our modules. Because that would leave you in the situation that you have to cover something that essentially exists here as well. What we do, we transfer the conducted courses from abroad as given in the areas. So as long as it fits in an area, it will be transferred. This should extend the course selection possibilities for your studies. That's another reason for a stay abroad. And specifically, if you want to head for academic careers, it's almost mandatory nowadays to have some intercultural competencies in your CV somewhere. So, and also, of course, if you want to go into international labor, if you want to work somewhere in the world. So those are potential reasons. Let's just assume you do have good reasons for yourself to stay abroad. All right. So what are the possibilities then? Well, first of all, the regular exchange, either in Europe, the Erasmus Plus system, to be more detailed, or overseas, worldwide. We do have roughly above 30 countries in our portfolio. That's a bit outdated. I think we're at the moment roughly 90 partner universities in our department. I have a new colleague since 1.5 years roughly, and she's very eager to create new partnerships. And we're working on several others at the moment as well. The duration of stay would be 1 and/or 2 semesters. That depends on the partnership contracts. So at some partner universities, it's only possible to stay abroad for 1 semester, then either in the winter or the summer. Semester on our side, right? And sometimes it's even possible to go abroad for a year to a specific partner university. Most of the partner universities, you do have a somewhat decent selection of English taught classes available. That differs a lot, even within the same country. Just as an example, we do have a lot partner universities in France, and some of them have completely English study programs as well. And in some other partner universities, you can probably take 2 or 3 English taught classes. if your French is on B2 or C1 level, Montreal would also be an option in Canada. We usually don't use this possibility because no one wants to head for some French-speaking university. Hint, hint. But of course, South Korea, for example, but it comes down to the countries as well. Japanese universities don't tend to offer that many English-taught courses in general. In those cases, you will actually conduct a research intern, for example, and you will only get very few credits after returning back for the same. But the intercultural experience, of course, is a completely different one. So, different reasons, but that's a regular exchange. There's the partner database on the central websites of the university, filter computer science. Not every partner university of the university itself is also partner university of our department. So set the filters in the right way, and then you should have an up-to-date overview of the current possibilities to apply for a regular exchange. Another option would be a double degree program. That's a bit interesting because usually students have to apply before they start the masters. But as your freshmen, it should be applicable to apply in the second semester, and actually then after the second semester probably leaving the country for the year. A double degree is essentially just studying at 2 universities, part of the time University A, part of the time University B. There's a plan how to transfer credits in each direction to fulfill the criteria on both sides, and at the very end a co-supervised thesis, and then you get both degrees. We are continuously working on double degrees. I think we renewed the ones with the new regulations in Grenoble, probably Lyon, not sure. We're working with Eurecom in France. We have one in IT security with either Politecnico di Torino or Trento, Italy. We're on our way to create one with Bucharest. There is one in the IML with one of the IITs in India. And so on and so forth. If you're interested in double degree programs, definitely join us in one of the exchange consultation hours in the next weeks to clarify the details, because we may probably in that case speed up the internal communication with the partner universities to make it fitting. And if you go for a double degree and whatsoever skip in the middle of the program, you can just come back and still get our degree, right? I think that's one of the reasons why so few students go for double degrees, thinking that they will lose both degrees if something goes wrong, but that's not the case, right? On the other hand, not that many double degrees anyways, and most students just tend to go for 1 semester abroad. So those are the programs offered by our department, essentially, or where we have contracts from our department and other departments. And there are several other options, of course, because, and now getting back to that. Oh, nice. Damn. Anyways, the lead time. Lead time for regular stay abroad, 1 or 1.5 years, roughly. So the next application period for the possibilities in the Erasmus Plus system that are either new or not used in the last application period in November will be in May. So you should, during this month, actually see a new possibility list popping up on our websites and outside of our office, D115 downstairs. Not that many possibilities, because most students apply in November, because then the overseas possibilities are also given. Anyways, if you apply, the earliest time to go abroad is a year later. So if you apply in November and get accepted, the earliest semester abroad would be next year winter term. And then you should somewhat be done with your degree almost. That's not a selection criterion for us as well. We are sending out master students on regular basis that are actually done with their degree. There are several possibilities to block the degree, and then just go abroad, cover into go for the intercultural competency, go for some courses. Then it really doesn't matter whether you receive good grades, for example, easing the situation probably a bit as well. for us, it's definitely not a constraint. So if you're interested, go for it. Being abroad usually extends the studies by 1 semester anyways, statistically, because you want to see something from the different country, probably not rushing too much in the studies there, and. Not every course is fitting. So essentially every stay abroad, or almost every stay abroad, extends the studies by 1 semester, so you have a good explanation anyways. Think about it, right? So up to 1.5 years lead time for the stay abroad then, if you get accepted. There are other yeah. So the question was whether it's possible to leave somewhat in the middle or end of the master's, staying abroad, and then returning and finalizing the thesis here. Okay, whether it's possible to finalize or conduct the thesis abroad. Yes, but you need a professorial supervisor from our department for the stunt. It's a regular achievement for the studies. So you can. It comes also down to the regulations of the partner university. Sometimes they need you to register it as a thesis officially, and then legal base comes into play. Sometimes they just say, well, but you need to conduct a few courses at least as well, and what you do in your free time is your decision. And so there are several options and differentiations. But yes, we had several students staying abroad conducting a thesis on several programs and several levels. There's actually, I will get to another option for the same in the third point here on the slide, right? So, and there was a remark to the point, no? That's exactly the difference. Exactly. So the question is, do you necessarily need a supervisor on the other side as well? No. That comes down to the rules of the other university. If they want to have you registering the thesis correctly at their university, you will most likely find a supervisor there as well, right? If they say go for some language classes and whatever you do in your free time is fine, then it's somewhat like an internal thesis here, right? So it's from university to university is different, to be honest. You always, that's GET, General Examination of the University, for a thesis in our department, you always need an allowed supervisor from our department. Exactly. So, that's exactly the combination for the third point. I will get back to that in a few secs, right? So, any other questions at the moment? All right. Besides the regular exchange, double degree and Erasmus Plus or overseas regular exchange, there are some other options. For example, Hessen programs. We, as a department, don't have any possibilities in New Zealand or Australia, and not that many possibilities if you're still interested in the US, for example. Why if you're overweight, probably don't try to get in the US. If you're not looking that wide, probably don't go into the US at the moment. They have nice camps where they locate people like that. Anyways, the Hessen programs, there are 3. One is actually with Australia as well, Hessen Queensland, and then it's Hessen Massachusetts and Hessen Wisconsin. Different application periods, slightly different for 2 of them. One is completely different with all the application process. It's not of our department. We are not really responsible. So you have to apply in the International Relations Office, and you apply with all the Hessian students. But there are several partner universities in each of the states, Queensland, Wisconsin, Massachusetts. So you have a bunch of possibilities to select from, and the acceptance ratio for those programs from our department point of view and the university point of view is quite high. And you can go for both in the application period in November, because 2 of the applications for the Hessen programs are a bit earlier than our application period in November, and you can start with that. And if you are rejected in the first round of the process, you will still follow our application process. And if you got accepted, the chances to be accepted finally are quite high, and then you will be removed from our procedure to make it more applicable to send out more students. Right? That's the base idea. So Hessen programs. Look up the information on the central websites, on the Hessen programs, quite interesting universities. You can, of course, as well go abroad just self-organized. With respect to transfer of credits, no difference. If we get a transcript and the courses are matching, you will get the credits transferred. But the big benefit of contracts between universities is that we skip the high fees, right? So, of course, in some countries you will still have to pay fees for courses, probably living expenses, dormitory fees, something like that. But this very high, big bunches of money in the UK or the US, for example, you don't have to pay. If you stay abroad self-organized, you probably have to pay. And not every university is accepting so-called free movers. You would be a free mover then. For example, TU Darmstadt is not accepting free movers as incoming students, right? Some other German universities do. So therefore, you have to select then universities where you can actually apply. They do have information on the websites. Can be way shorter lead time, way more possibilities worldwide, but way more workload to prepare, of course, and gather the information on your own. If you need help for transfer of credits, course selections, whatever, if you need recommendation letters and at end, same as the regular exchange, just drop by, let us know, right? If you get a scholarship for the same, it might be way easier. Studienstiftung. Die Studienstiftung des deutschen Volkes. It's a name, so I'm not translating that. If you get a scholarship, it can be up to, I think at the moment, 10,000, 12,000 euros a year for a stay abroad. So we had students who have been at MIT, Stanford, Cambridge. So if you can manage to gather some kind of scholarship sufficiently high, really cool combination of universities existing where you can stay abroad. Okay, and last but not least, I mean, staying abroad doesn't necessarily mean to extend the studies. You can gather different competencies, like, for example, international work competencies, just do an internship. There are several platforms, DAAD, for example, that's the German Exchange Association, Deutscher Akademischer Austauschdienst. You will find a database for European companies offering internships. And you can even get an Erasmus Plus scholarship for the same, right? So that's one option. If you do a research intern, it might be applicable to get some credits at least for that, but it has to be discussed on an individual basis. And the Erasmus Plus internship program is the thing I mentioned earlier. You can as well stay abroad for 2 to 6 months, I think, at the moment, also at other European universities, and we don't even have to have a partnership with them, and just do something there. You're not allowed to take regular courses, and it's explicitly meant for research intern, and that is mostly the option students go for with a thesis. And if a professor here, for example, has befriended professors or professors working in the same research project somewhere in Europe at a good university, they can organize that. And the lead time is minimum of a few weeks, actually, because you just need an invitation letter from the other side. And a few steps here, way easier, way faster, but solidly meant for research, right? Also, Erasmus Plus internship possible for the same. Pardon once again? No, you're not enrolled there as an exchange student or as a student at all. You're there doing an internship. Sometimes you even get a bit of money. You don't have to pay any university fees or whatsoever, but more expenses probably because of flats, dormitory places, and whatever probably. But that's the reason why you can get the Erasmus, automatically, the Erasmus Plus scholarship. Not that much, but at least a few €100 per month, for example. Sorry, I didn't repeat the question. The question was whether the advantages of the contracts also hold true for the research intern thingy. Yeah. Not necessarily, because not really given, and partly yes, so it's an interesting combination of yes and no. Noch aus.
Okay, so 2 questions. If I'm going on a self-organized stay, do I still have to wait the 1 year?
Depends on the application process of the university. Also just depends. Sometimes, okay, in Southeastern Asia, for example, Japan, South Korea, Taiwan, North America, you usually have just 1 application period for an academic year. In that case, and that usually is somewhat March to May each year, for a stay abroad in the winter term and the following summer term. So it would be a bit shorter, probably. And in Europe, it can be way shorter sometimes. But it might also be similar. So it really comes down to the university and the country.
And the second question, if I'm in contact with a university who would be interested in a contract with TU Darmstadt, who should I talk to?
Us. Linda Frey, or just the exchange email address, abroad@CS, Ausland@Dekanat, Ausland@Informatik, and so on, leading to exactly the same place. And then we as a department can start the process. Another option would be to get in touch with the International Relations Office, and they will let us know then. So both options applicable. It's usually way better if the colleagues from the other universities are getting in touch with us, not the students. Any other questions? All right. So we already talked about the options and potential reasons. So let's assume you decided you want to stay abroad. There are good reasons. I'm interested. First of all, you should ask yourself the question, what's the best time for me under the constraints to stay abroad? So, planning ahead. Okay, I've selected a few options and I planned ahead. When do I need to apply? Because exclusion deadlines sometimes, right? So even a minute too late, that's it. So when do I need to apply for the options? And then, of course, my personal interests, right? Even though you think, okay, Europe is fine because of the scholarship and I know when to apply, there are still several options and you're enrolled in different programs, your field of interest is different, so you need to look up the partner universities and the experience reports up to a point that you get an impression, can I actually take a sufficient amount of courses in my field of interest? Which prerequisites have to be given, like specific language certificates, specific language level, for example. X semester, X credits already covered, something like that. In the partner database, you will find fact sheets and experience reports stating living expenses, links to the partner universities, experience of former students being there, and. We're at the moment working on a tool where you should be able then to request a credit transfer after a stay abroad and building up a database, because at the moment we're just looking up all the PDFs we created. If you have questions on course selection possibilities for partner universities, because we are the theoretical University of Darmstadt. Can I afford the same? Another really important question. On regular base, we had students who were nominated for the US, and a stay abroad in the US for one semester roughly costs you 12,000 euros. roughly. Probably a bit more at the moment. Not many scholarships. The Fulbright scholarship has to be applied for, I think, 1.5 years earlier as well. So sometimes before you even know whether you want to apply on our side. And then, yeah, the funding was not working out and they skipped out of the program or the nomination somewhat in the middle of the process. That's okay. No one else can use the place then, but that's fine. Shit can happen, right? But if you, of course, already know in advance that you definitely can't afford it if you don't win the lottery, probably don't apply for this possibility. Yeah, and the language certificates, and that's really different because even in the same country, the universities are accepting very different options for certifying the language skills. Sweden, for example, a partner university of ours, accepts that I sign that you have a B2 level in English. Hint, hint. South Korea, either the EVHA or Seoul National, I'm not really sure about that, accepts Duolingo. And Duolingo actually has a certificate system as well. It's not your Duolingo app thingy. There are test centers, almost as expensive as the IELTS or the TOEFL. North America solely accepts TOEFL or IELTS because they have contracts with the companies offering the same. A colleague from ETS, the company offering the TOEFL test, was here a few years ago and we had a nice chat. I got to know several details about how the system in the US works with the payment of language certificates. Some are actually like, oh yeah, come on, they are selecting their students. We just assume they have the right level. Individual base, always. You have to read up a lot of things before you decide, right? That's probably the most important part of this slide. Start early. Read. Get in touch with former exchange students, with current exchange students being here, and, just to narrow down your idea selection in order to speed up the process and make it more secure that everything at the very end worked out in the perfect way. So the thing we are hoping for is you return, and if I ask you, how was your stay abroad? Awesome. No issue, very cool, cool experience. I now got married to a local. Happened a few times. Some other students actually are living now in the countries they've been abroad. Thailand, for example. So something like that. We also had couples breaking up during their stay abroad. So okay, so the application. As I said, there is an interim possibility in May. Have an eye on our websites and visit us in the consultation hours. But all the possibilities, except one of the Hessen program, or all of them actually with a deadline, is November. And the exclusion deadline for the applications is the last day of November. Because you have to apply via a tool from the International Relations Office, and at midnight, it's done, right? As soon as we have information, we are unfortunately, we need to wait for the information of the International Relations Office the whole time through. And my colleague is actually on holiday this week, and I forgot where they put the lists. So either it will pop up by end of this week probably, or during next week, the list for May, and usually within the month before the application period officially runs. So in October, the final possibilities for November, because up until then, we can still finalize contracts. And that would lead to more options for you. So we're waiting for a sufficient amount of time, but at some point, we need to deliver the information. And what you need to apply in our department is the application PDF that's generated via the tool. Forget about that. A bachelor's transcript, if you have not, or in general, the transcripts, if you have not conducted the previous study programs at TU Darmstadt. If you have conducted, finalized your previous degrees, programs at TU Darmstadt, just upload an empty sheet of paper. You need to upload something. Empty sheet of paper is fine. We have two-kind backend access. We can look up your degrees, if you did them here. A tabular CV, And that's really important. So, short excursion on how our selection procedure works. We need to make it somewhat fair. What's fair? Numbers are fair. So, we're trying to, first of all, comparing grades and credits per time, so speed, right? How fast you studied, how good you studied. But we're a quite nice department, and we know that there are several reasons, an arbitrary amount of reasons, why it might have taken you a bit longer, or the grades are not as good. Handicaps, committee work, taking care of relatives, hospital stays, whatever. But we don't have the information ready steady. So we need you to add that to an additional page attached to your CV. Just enlist everything you think might play a role for our selection, because then you have lower points for grades and credits per time, and you get bonus points for the valid compensation, right? But we need to know. What we do then, putting points on all the factors, then we have clusters with the same points, then we're diving into the next two things, plan of studies and motivational letter. I'm going to explain that a bit more detailed right now, after what I just say. And with the additional things in the CV, the plans of studies, motivational letter, we're adjusting the same graded applicants. And then it's dynamic programming, linear optimization. First place in the ranking, first wish, because you can apply for 5 possibilities. Granted. Do we have more possibilities at the same university? And we mostly have 1 or 2 places per year at a partner university. So if yes, everything stays within the wishes as given. Ranking moves up by 1, next first place, first wish, granted. No further possibility given, the wishes are removed. All the other wishes in priority move up by 1. Ranking goes up by 1, first place, first wish granted. So if you want to apply, and if you think there are probably some factors influencing what I did before, enlist it in the CV. It's really important. The plan of studies. 1 document, please. For all the 5 wishes, all the 5 potential partner universities you apply for. And it's not possible to completely plan ahead at that time. What we want to see here is, what's my plan here before I go to stay abroad? What would be my plan for the respective partner universities? And why is there at least a decent chance that it works out? And the last point can be argued. For example, they offer an AI program. That makes it quite likely that you can choose some AI courses there. Experience reports. The student last year who already gave the experience report stated that he took several courses. I'm very interested in the same field. Completely fine argumentation. I got in touch with the professors there and they allowed me to join by now. Would be strange, but okay, fair enough, right? So anything that leads to a decent argumentation why it's applicable. And you don't have to dive into specific courses. You can enlist courses, but you don't have to. I want to go for X credits in the field of, and it's quite likely that that's possible because of. Would be fine. The situation you're in before you stay abroad is most likely the same for all the applications you go for, right? So, introductory section, and then short sections for every wish you've selected. 1 document. No copy-paste bullshit, please, right? Same for the motivational letter. One student actually submitted a motivational letter a few years ago why we should be motivated to send him abroad. That was interesting, 0 points. Why am I interested? Why am I motivated for a stay abroad? Introductory section. Why am I motivated to stay abroad in a specific country or specific countries, if you have more than 1 country you want to go for? Why am I motivated to stay abroad at a specific partner university in said country? The last part may overlap with the plans of studies. Cross-reference. You don't have to copy-paste bullshit. Cross-reference. It's mainly contentious reasons why I'm motivated. See the plans of studies. Completely fine, right? And the motivation to stay abroad will always be the same for every possibility, or at least mainly. And the motivation for a specific country will also be the same. So reduce it to the minimum, but in a way that we have all the important information. If you have questions about the documents, of course, there will be informational events as well and all consultation hours. That's what you need to submit here for the application. And now, a short explanation why the lead time is that long. Let's assume November. You apply. We can start our selection process on first day of December. There's a winter break coming up. What we do, sending out the not provided possibilities to all students who have applied, but where we were not able to select them because they were too low in the ranking or too few places at the partner universities or whatsoever, right? And then you can ad hocly redecide, without sending further documents or whatever, during the winter break, that you want to go for some other option that is still left over. On January 15th, we're finalizing our selection, sending that to the International Relations Office. They are checking for some formal criteria. Then you will receive a so-called Annahmeerklärung. You have to send back within a week, I think, usually. Then, a bit later, they will nominate you, because the university has to nominate officially, they will nominate you at the partner university. They will check some criteria. Then they will get in touch with you, and then you have to apply at the partner university as well. And here you may actually have to submit some other documents as well, recommendation letters or whatsoever. And if you got accepted there, you secured the possibility. And that should be somewhat summer then. And the earliest point to stay abroad is the winter term, so the lead time is actually not that long because of the very complicated process, unfortunately. Right, so if you need recommendation letters, try to get them in really early. It sometimes takes ages for professors to submit something like that. If you need that quite soon before you conducted any courses here, for example, and whatsoever, just drop by. I do have drafts on my computer. I can get professors to sign a quite generic recommendation letter for you. It is not really a big point in the application process for most universities. Anyways, there are differences though. Paris. Telecom Paris Tech, for example, and so on. They have an eye on grades and recommendation letters and whatever because it's fucking Paris. I don't know why. We had very few partner universities rejecting our students when we nominated them. Paris. Strange contract at that time, one of the IITs in India, UBC Canada, and one university in Japan. 4 cases in the last 15 years when we selected students and the students followed the processes, only 4 cases that they have been rejected by partner universities. Last semester, actually, 1 in Paris. 2.7 CGPA was too bad for them, right? So, and you can't always see the criteria. If in doubt, drop by. Let us check that, right? All right. So, and besides the consultation hours, where can you gather the information? On our websites, of course. On the websites on the International Relations Office, you will find the partner database there. You can just also Google Partner Datenbank TU Darmstadt. In the consultation hours, via email, good luck with that. We do have information events in the summer, mainly because the main application period is November. In the summer, there are information events offered by our department and from International Relations Office for specific types of mobility programs, specific countries or regions, and. And they also have consultation hours, one via Zoom and one in presence, I think, at the moment. All right. That's essentially staying abroad at a short glance. Questions? the internet has questions. The internet always has questions.
We have one question online. If I'm an international student coming to TU Darmstadt, is it advisable to consider a study abroad period for me?
Okay. It's possible. Depending on the personal reasons and situations, it might either be a good idea or not. I mean, the benefit of gathering intercultural competencies is already given, but you can always gather more intercultural competence. So I'd say if you're interested to get some new impressions, other courses or whatever, go for it. There's no real reason to not do the same, but whether there are reasons to go for it depends. So, further questions? That's it? Yeah, Belal. The international mentors have questions. Pardon, what? Whether it's possible to do an exchange in Russia soon. I doubt it. And that's really, really sad because we had an exchange with St. Petersburg. And that's a real good university. And this fucking Kremlin destroyed everything. I don't think so. Not in the nearest, not as long as you're still studying here, most likely, to be honest. We also have no option at Ukraine at the moment. Israel might be skipped for some time, probably. They're in discussion with the Auswärtiges Amt at the moment, of course, due to security measurements. But we have Bulgaria, Romania, so nearby. We're working with Hungary on a contract at the moment. That's almost Russia. At least Orban is. But Russia is out of scope at the moment. They're paused. They're not completely deleted. It's just paused. So probably, if the situation changes, at some point, it will be applicable again. Hopefully because, really, St. Petersburg, lovely city, lovely people, really good university. Other questions? Non-joke questions? Yeah, okay, the question is whether someone has to sign the same. Or, I mean, okay, the question is about the transfer of credits. How to decide whether it will be transferred or not, right? The person advising you before you stay abroad, the person finally deciding which credits are to be transferred because the explanation board told me to do so. So, before you stay abroad, if I tell you that's definitely applicable for a specific area, it will also be transferred after returning back in that area. Probably there are even more options after returning home. But what I agree on or state will be given. So, and it's not that hard to decide, to be honest. The benefit is I'm a computer scientist. You can actually mainly choose by name of the courses already. But another interesting thing, fitting this point, this distinction between seminars, labs, and lectures is a very German and very TU thing. In most of the other countries, you have a mixture of a lecture and then either projects, labs, final project, or small seminar parts. And then you can decide after returning to TU Darmstadt whether you want to have it transferred in the elective areas with the exams or as a seminar or lab. So a lot of options. We're transferring, we're accepting way more than 90% of the conducted courses for stay abroad. So the chances are quite decent. Any other questions? How long was the talk planned to be? Ooh. have a lot of time. Let's dive into automata theory. Let's assume you have a language that's NP complete. And assume furthermore you have a second language you could reduce to said language, but it's solvable in P. Which statement follows from the same? We had some exchange students here in the winter term. They had to give a complexity exam orally. I was the protocolant. We asked those exchange students this question. They answered it in no time. And one actually was, yeah, but that was not really content of the complexity theory course. We had that in a course a year ago. We just remembered. The right answer is P equals NP. So it's a fun joke question, of course, but you can learn so many different things in other universities. I mean, that was probably for most of you not the best example. I assume. I'm a theoretical computer scientist. I really love the answer. But that shows how they put different focuses on different areas, how they work with the same topics. If you do the reinforcement learning here, and you take a reinforcement learning course at a university abroad, there will be differences. Even though the theory is similar, you will get a completely different point of view on the same. So you can actually strengthen your competencies knowledge. And it's so interesting, even though the course names are almost equivalent, the same, identical, and it looks like the university systems are very similar, there are so many differences and so many cool things you can actually gather out of a stay abroad. So if you're interested, really dive into it and keep yourself motivated, right? Even though it's hard to gather all the information because really we just had very, very few students returning to TU Darmstadt who were not really pleased and happy with their stay abroad. Even if there were some struggles or whatever. I can highly, highly recommend this possibility. Unfortunately, during my diploma studies, was not able to stay abroad because the diploma studies were not comparable to anything. We almost had no option. I would have loved to stay abroad. No option. So I missed it. Don't make my mistake. Stay abroad. If you have further questions, just get in touch with us. Let us know. Oh, there's a question from the internet again.
Yeah, 2 questions from the internet. What happens if I fail a course abroad? Does it affect my degree here?
Interesting question. No, not at all. You request which courses should be transferred after returning to TU Darmstadt. So if you request a failed course, we will reject the same anyways because you would really run into issues. Because then, and us as well, because we would then need to make sure that you can actually finalize the course we're probably not offering at all. So no, we're not transferring failed courses. But you're ambassador somewhat of our department. So just going abroad to surf a bit and failing all the courses is probably not the best idea. Failing a course because you misjudged the level or the content or you were surfing, something like that is completely fine, right? Can always happen. But yeah. It is somewhat considered as a free attempt then, right? Exactly. Wait, just a question from the auditorium. The question is whether it's possible to stay abroad more than once. Yes, there is no restriction. You will only get the Erasmus scholarship for for actually 10 months, because it's 5 months per semester, for 10 months in total per level, bachelor, master, doctorate. We had situations, students who went abroad to South America, for example, in the first master semesters, applied from Colombia when they were abroad in May for a follow-up stay in Spain and got accepted. He returned and directly went to Spain. So yes, definitely possible. Not easy to plan ahead, but possible, definitely. And as I said, there are options to block your degree. So, and by numbers, 63 years, passing 3 credits every second year. So essentially you can stay abroad a lot if you want to.
So here somebody asks, do I need a visa if I want to stay abroad?
Do I need a visa for a stay abroad? Depends on your nationality, the country you want to go abroad for. If you're a European citizen and it's a university in the Schengen-Raum, then you most likely don't need a further visum. For other countries, of course. There are usually specific student visa, as the international students may know, right? Yeah.
Then we have another question. I was already abroad in my bachelor's and am now thinking about it again in my master's. Only from a study point of view, would you recommend a second stay abroad?
If one of the valid reasons for another stay abroad is given, go for it, right? And you will always find some new experience, some new content, some other perspective on the same content, and. I mean, if you do a stay abroad a second time at exactly the same university in the same country, probably not so much, right? But besides, of course, so from my point of view, there is no reason to not stay abroad. Okay, the question is, wouldn't it make more sense to, if you just arrived in Germany here, to work on your German skills, get settled in Germany, the culture, whatever, besides jumping around the countries, right? Depends. I mean, if you want to stay in Germany for some time, it probably makes more sense to get to a higher German skill, for example, because that definitely enhances the chance to get a job in Germany. Definitely. Definitely. Whysoever, even in international companies. German language skill on a high level is really important to get a job in Germany, still. Then, yes, probably. But if you want to work in somewhere in the world, for example, in probably academic career, it might make more sense to collect more intercultural competencies. No. Hessian University law states that students who are not able to pass at least one achievement for their studies after every second year, 4 semesters, can get exmatriculated. And if you pass 3 credits every second year, you can correctly stay enrolled for 63 years in our master's degrees. Not a recommendation, as I said yesterday. We had some students who tried the same, probably.
We have another question online. Can I somehow go abroad together with a friend at the same time?
Okay. Probably. Definitely see us in the consultation hours, because you need to know for which universities we have more possibility than one per academic year. Otherwise, it's not applicable in general. If we can manage to combine that, we will. We did. As I said, we had couples breaking up. Not the best idea to stay abroad together, probably. We also had friends going to the same partner university together. So yes, no promises made. But if we can support that, we're going to try at least. That's it. No further questions, at the moment, at least. All right, have a nice sunny afternoon, and probably seeing a few of you then. I'm attending the smoking pub tour for the first smokers pub. All right.
Okay, so in a quarter of an hour, the lightning round is going to start here, so at 3 p.m. But until then, you're free to do whatever you want. Okay. Then, welcome to the lightning talk. We're now going to have 3 short talks. First of all, from the darts racing team, then from the TOD SAT, and then later from Janus from Hessian AI. And yeah, thank you for coming, and the stage is yours.
Yes. So my name is Patrick Weilbach. I'm a computer scientist student at TU Darmstadt with a specialization in autonomous systems.
Hi, I'm Lisa. I study electrical engineering in my 6th semester. Yes, today we are here to introduce you to Dart. Yes, what is Dart? Dart Racing is a Formula student team, which means we're a group of students participating in an international engineering and design competition. As part of this competition, we design and build an electrical car entirely on our own. From the concept and development to manufacturing. Yes, at the moment we're currently working on the Tau 2026. Yes, a few informations about the car. The weight, 205 kilograms, 109 horsepower. We have all-wheel drive, we have a battery with 600 volt and a top speed of 100 kilometers per hour plus. So what is Formula Student exactly? Formula Student is an international engineering and design competition where student teams from all over the world compete against each other. They are held in events in different countries, for example, Czech, France, and most important, Germany. These are also the events that we're driving in this season, in this summer. The competition is also strongly sponsored by the industry, for example, Porsche, VW, and Bosch, but many more companies. So how does Formula Student actually work? Teams collect points in different disciplines, which are divided into static and dynamic events. The static events focus on engineering side, such as design process, where the teams present and justify their technical decisions. And the dynamic events, on the other hand, they take place on a track. These include disciplines like acceleration, skid pad, and the endurance race, which is 22 kilometers. Which is the longest race. Yes, and finally, all teams are evaluated by judges from the industry, including experts from Formula 1 or other companies like Porsche and Mercedes. So let's start with a quick video to show you who we are. Okay, unfortunately we don't have sound, but I think you, from the pictures, you got a little overview of what we're doing. Now let's take a quick look at how our team is structured. The dart racing is divided into several departments. Each department focuses on a specific part of the car, and we all work together, closely together, to build a competitive vehicle. Now we take a closer look on each department with special focus on the autonomous system. So first, the chassis. Our monocoque weighs about 21 kilograms, which is very light. It's out of carbon fiber, built in the sandwich structure. And for the next season, we will have big changes because we're changing the whole monocoque. In the picture, you can see our old form. In a new season, we will have a totally different one. Then the management. Management is all about sponsorship, acquisition, marketing, social media content, but also business plan and cost analysis and project management. Then we have vehicle dynamics. It's about lap time simulation and regulation, especially slip control and torque vectoring, but also virtual race engineering, which is very important to validate for development. Then we have the powertrain. We have in-house developed motors with planetary gear and a completely self-developed inverter, which we have the first time in this car. Then we have aerodynamic. Aerodynamic is about the front wing, the side wing, rear wing, and the nose flaps. You can see in the picture. We use CFD simulation for the flow analysis. And it's all about generating downforce and reduce the air resistance. Then we have the undercarriage. Undercarriage is everything that connects the car to the road. Tires, wishbones, steering, springs, and a damper system. You can see them a little bit in the picture. Yes, and for next season, we will have smaller tires, which makes us faster and competitive. And for that, we need new kinematics and a whole new spring damper system. Yes, then the accumulator. I'm actually the head of this department. We have 600 volt, we have 140 LiPo cells in 10 modules. We have a capacity of 11.3 amp hours and a completely self-developed battery management system. The accumulator is basically divided in two parts. We have the electrical engineering side, which is all about cell integration, PCBs, and the software. And the mechanical side, which is about housing, cooling, and the packaging. Then we have the ETIT, that's our electronics department. I'm also head of that department. We develop, manufacture, and maintain our PCBs that we designed ourselves. Design and construction of the wiring harness in the car, but also integration and evaluation of the sensor data and embedded software development in C++, but also the telemetry. So next we have the autonomous system. We use a LiDAR system for that, state estimation and SLAM for the software, and project planner and the control. But more about that from Patrick, because he's the head of our autonomous system.
So now I'm going to explain you a little bit deeper about the autonomous system and how it works in our system. So here you have a high-level overview. So we have sensors where we can perceive the environment and also the internal state of the vehicle. It follows the classical cycle of a robot system. We're having a sense, then a planner, and then acting. That's typical for robots, and when we perceive our environment, then we are getting the correct features out of it, and then can steer the single motors to do some actions in the environment. So a little bit more about our sensors. So here you can see our sensors and where they are all located at the vehicle. We have a ground speed sensor, it's an optical sensor. then a LiDAR for the perception of the environment, then an inertial navigation system, a steering angle, and motor appearance to calculate the internal state of the vehicle. So a little bit more about the single sensors. The LiDAR is a light detecting and ranging sensor. We have a LiDAR-only system, so other teams use some fusion systems. They're using cameras also, but we only use the LiDAR as the LiDAR gives more precise information than cameras. It has a field of view of 115 and 22 degrees. It can range up to 250 meters, but as the dots there are a little bit more, the resolution is not so good, so the actual perception range is about 80 meters of our system. And yeah, it's a solid state LiDAR, so we don't have something rotating inside of this LiDAR, so we can only view a solid state, so meaning in front of us directly. Here you can see the Ophase raised ground speed sensor and the different stuff it can measure. Most important there is that we can measure the velocity of the vehicle independently of the single wheels. This is especially important for the slip control, as we there don't need a mathematical model to calculate the velocity in correlation to the wheels. The inertial navigation system is a redundant sensor with another measurement system. And the benefit of this INS is that it has a GPS module inside, in addition to the ground speed sensor, so we can locate the car in a global navigation system, which is later more important for the SLAM algorithm. Then we have the steering angle and also the motor appearance, therefore we're using encoders to get these values out of the vehicle. Then more about the electronic control units we're using. So here you can see the perception SLAM for locating the car in a built-up map. And also the other components are all running on the ACU, the autonomous computing unit. It is a laptop mainboard which is optimized for weight. So we don't use GPUs for the perception as GPUs bring up weight and also power consumption. And we also have a custom water cooling implemented. For the electronics unit, we have a dev board, a FI-Core AM64 board. It can also run it can run an operating system, and also we have some cores which are especially for real-time application, where something like a slip controller and torque vectoring can run. This separation is because we want low latencies. As when we run all on one system, we have, for the control parts, too much latencies in our system for the controllers. So you can see how all these computing units interact with each other using their classical Ethernet protocol. So a little bit more about the software. In the perception, we first have to detect the plane. Then remove that, then we can perceive the cones, and then we can perceive the color of each cone. Therefore, we first filter out the plane, as you can see here in the picture, that we don't have objects that hopefully will be coins, but there we are then using neural networks, convolutional neural networks, to then detect if the object, the point cloud, is a cone or not a cone. These convolutional neural networks are especially optimized to run on a CPU. As I mentioned, GPU is too much overhead for us. Then our state estimation is there to compute the internal state out of the sensors, which we then need later for the control and the SLAM part. Therefore, we are using a simple Kalman filter. As I said, input of this is the single sensors. Sensor inputs, and output it is the velocity of the vehicle, which we can then later use. For SLAM algorithm, we have a SLAM master which does some data preparation of the inputted data for the actual embedding in an optimization problem. And therefore you have, so SLAM is simultaneous localization and mapping. So we have to build up a map of our track and then have to locate it inside of this track, the vehicle, and therefore we have to separate between open SLAM, so we are receiving we can develop a new map, and then when we have a closed SLAM, so mean we driven one round, we already know the track, and then have to only locate our vehicle more precisely in this build-up map. And therefore we are using something like a graph SLAM. It uses a probability distribution over relative locations. So in this optimization problem, the single sensor inputs get encoded, and then this optimization problem is solved, and then we get out the necessary outputs we can then further use to optimize the trajectory which the car actually drives. So in a track detection, we are getting the car out of SLAM, and then we can compute the middle line, which we can then use when we have the middle line of the car. Then we have to optimize this middle line, as we want to drive a most optimal line. And when we have an ideal line for the car, then we are simply tracking this line with a controller. And also some things you can do for vehicle dynamics is slip control. So therefore we are determining an optimal slip ratio over different slip profiles. And this is simply then a feed-forward speed limitation for the single motors. So here in this animation you can see it a little bit better. Therefore we are giving full power on the rear wheels. So the velocity of the rear wheels are not consistent with the velocity of the actual car. So we're losing much energy there. And therefore we're having a slip control to limit our wheel velocity to be most efficient with the actual car velocity that you can see in the curvatures. And here you can see the slip control in action on an actually test day. Unfortunately, we have no sound. But the only one you would hear is the motors. So next thing about vehicle dynamics would be torque vectoring. Therefore, we have a reference generation, so we're generating a yaw rate trajectory, and then have a simple controller which follows the global yaw rate. And then we have a torque allocation, so we're having a global torque rate, and then we have to put that on the single four wheels, and therefore we are solving an optimization problem to bestly distribute the torques on these single four wheels. And here's also animation which shows about torque vectoring. So we are distributing, so we can steer the single wheels of individually, and without torque vectoring you would simply drive out of the track as you have no steering, basically. But with torque vectoring you can replace the steering of the driver, and then you can simply drive corners. Yes? So these algorithms are not used for both. So in Formula Student you have electric vehicle class, which is with driver, and therefore you can also use this assistance systems like the slip control and the torque vectoring for the driver itself. But you also have a separate class, the driverless class, where you only drive without a driver, but therefore you can also use this assistant. Yes, but for the class with driver, we don't use the perception part. So the part in front of our pipeline. So only slip control and torque vectoring. So with a driver and without a slip control, the driver has to implement actually the slip control and the torque not the torque vectoring, but the slip control. And the slip control is simply algorithm to support the driver to get the most out of the car. So here you can see the actuators we have. We have 4 self-developed motors, which we can individually set the torques. We have a pneumatic brake actuator for braking and also a steering actuator. Here a little bit more about the specs of our motors, which you can see. Most important is that we can reach about 130 kilometers per hour. And here's the brake system of the car. Therefore, we have a solenoid valve to distinguish between a service brake and an emergency brake, as the autonomous system most of the time does not what it should do. Therefore, we have to implement an emergency brake that we can safely stop the car. And here's a little bit about our steering actuator we use. This is from a test day with driverless. Short video you can see. Unfortunately, the LiDAR point cloud on the upper left part is not really visible, but on the right you can see what it does in the real world. On the left, you can see the environment, the simplified environment of the car it has perceived from its environment. And on the right side, the single states of the sensors we read.
So let's talk about advantages of Dart. The good thing about Dart is that you get in contact with companies, you can network with them, but also practical application of the theoretical knowledge that you get here in a university. It's also very good for improving your CV and to gather experience. It's actually very cool. We have a good contact with all the companies. They often invite us, e.g. Schaeffler invited us to the DTM final last year. Skoda, which is our biggest sponsor, invited us to come to Czech to see how their rally cars are manufactured, which is actually very cool. Yes, what do you need to bring? Experience is desirable but not required. You will get mentoring by former experienced team members, but also training by your department lead. But what is most important is team spirit and the motivation to learn new things. So if you want to join us, you can always apply for this season or next season. Next season will start in September this year. Yes. So thank you very much. And if you have any questions, you can ask now. Yes. Sorry again, I... Yes. Yes, we have a very long rule book that we have to follow. Yes. No, they change it every year just a little bit, but for next season there will be big changes with the chassis and the aerodynamic. Yes?
This is a class higher. This is the autonomous team of another class. So this is Formula Students. It's for students especially, but what you mean is for a little bit higher for doctors, PhDs of other. So they are competing MIT, Munich. It's actually on F1 cars. So we are building smaller cars, like in a go-kart format.
Sorry, if you got any more questions, I guess you have to visit them and ask them there. Thank you very much. So, next up is Tutsat. Also with the video with no sound. We're sorry.
My idea is they make the song. Yeah, that was the problem.
Brrr. Yeah, the issue is with the electric cars that you can just make brrr because they don't make that sound. So, but for rockets, maybe, yeah, zoom, vroom. Here you go.
Thank you very much.
Muted.
Okay.
Windows mute, just dot.
Yeah. Okay, there we go. Ah, there we go.
Test your setup before you present.
Yeah, if there's time for that. Okay. I would like to start with a question. Which of you has watched the launch of the Artemis 2 rocket some days ago? Okay, that's cool. And who of you watched the launch of the Ariane 6 rocket some month ago? Okay, yeah. And which of you watched the launch of the Frodo M rocket? Okay, that's more a joke. But it's a shame that you haven't seen it, so let's take a look together. And as we don't have sound, we will generate the sound on the fly. And you can hear us countdown. And you will soon hear ignition and then white smoke and liftoff. that was our last rocket that flew in 2024 at the European Rocketry Challenge in Portugal. So the question was more like a joke. That's what we do. We build rockets. Our rockets won't fly to the moon, but I can tell you, bringing a rocket to 3,000 meters into the air is already hard enough. So let's take a closer look. Here's also some footage from inside the rocket we wanted to share with you. And that's apogee. And that's the beautiful landscape of Portugal, somewhere in the middle of Portugal, in a military base. And that was the parachute. Okay. Next slide, please. Oh, I can also use the well, what rockets do we want to build? A bit of gunpowder, a fuse, and then just run. That's how humans building rockets for a really long time. This image here is from 1695, and that's how firework works. Transporting anything with that is really hard, and maybe not the best idea. So maybe we need something more controlled. So what we actually want is fly at 3,000 meters. That's the goal of our rocket. And do that in a safe and controlled way. Also, we want to recover the rocket safely. Otherwise, it wouldn't be a rocket, but a missile. And that's not what we do. And of course, we don't want to harm any humans with our rocket. So what is needed to launch a rocket? Oh yeah, that's that's our rocket. On the top side here, on the bottom, you see the rocket that launched at 2024, the video you saw previously. And the upper one is our next rocket we will maybe talk later a bit about. So what do you need for a rocket? So that is just a high-level overview, but every rocket needs an airframe, so that's the outer frame that gives the rocket the shape of a rocket. Of course, you need electronics to stay in touch with the rocket and to control the rocket. You need a parachute. We already talked about that. Otherwise, it's not a rocket. And you need a motor to lift up. So the most obvious part of a rocket is the motor. In general, you have three types of motors. You have a solid motor that's similar like firework rockets. You have a hybrid that have one liquid part and one solid, and you have biliquids. Frodo M was a solid motor that was bought off the shelf. That's a reasonable starting point for your rocket series, and people are building rockets like this since a long time. The solid motor, you combine your oxidizer and your fuel with one solid mass. And to ignite that from a safe distance, you also need some electronics and software, but we will talk about that later. The next bigger step would be a hybrid motor. That is what we are currently working on. With a hybrid, you have one liquid component and one solid. That's why it's called hybrid. In our case, we are using nitrous. Maybe the party people among us know it as laughing gas or nitrous. The other part is paraffin. You may know that from candles. Bringing both together in a form that it can lift a rocket is also not an easy task. For that, you first of all need a test stand to test your engine. And that's what we're developing or building since 1 year, roughly. And currently, our best try looked like the following video. Jonas will show you. That's the test stand, and that's the last hot fire attempt some weeks ago. And that's all. And that was already hard enough. But of course, that's not enough to lift a rocket, and it's still a long way to go for us until we can launch a rocket with that. Currently, we plan to launch our next rocket in October 2026, again at the European Rocketry Challenge. That is every year. So, still a long way. After that, we would like to build biliquids. And biliquid means you have 2 liquid components. For us, that would mean, again, laughing gas and ethanol as fuel. And you may know biliquid rockets from other rockets. For example, the upper stage of the SLS rocket that launched Artemis 2 was also a biliquid rocket that used LOX, like liquid oxygen, and LH2, liquid hydrogen. And also, biliquid rockets have an interesting history. The starting point for all modern rockets was Werner von Braun's work for the Nazis. And he developed the first biliquid rocket, and it was launched on Borkum at 1934, like this, something like this. And that was the Aggregat 2, and he called it Max and Moritz. And while this was for military and, of course, not for the good of humanity, that was in one development line with the later launches of rockets that eventually brought the first humans to the moon. But enough for the history, and let's talk about the parachutes.
Well, as said, we don't want to build missiles. So one of the main goals of our team or our rocket is to, in the end, have the rocket recovered safely. You can imagine there's a lot of time being spent for building a rocket, a lot of resources going into that, a lot of money as well. So in the best case, we want to have the rocket alive after the launch. That's what we need parachutes for. So at apogee, which is the main or the highest point in the flight trajectory, we deploy our parachute. It's usually a 2-staged parachute. So a drogue chute for slowing the rocket down, and then a main chute which safely brings the rocket down in the end. You of course need to deploy the chute itself, which we do with CO2 cartridges, which you might know from beer taps, for example. They use the exact same things. You can see them on the right side here. And we develop our own mechanisms. The one you see is a prototype. We basically have a servo motor which is pushing a kind of needle into the cartridge, opening the thing up. The pressure can escape, fills the parachute compartment of the rocket, which then pushes the compartment out and therefore the parachute itself. For this year's rocket, we plan to introduce an experiment, which you can see on the left side, so-called parabrakes. We do not want to have 2 parachutes. You can imagine if you eject the parachute, that's quite a violent process. There is a lot of pressure from the CO2 cartridges, which kind of shoot out the front part of the rocket. Then when the parachute catches air, the rocket violently flips, and we want to avoid this maneuver. So we plan to slowly open up some kind of umbrella, you might imagine, which you can see on the left side, the yellow part. So we got a motor which is opening that thing up, which will slowly or more slowly brake the rocket. The rocket will flip, hopefully not violently, and slow down due to the created drag from the umbrella part. The rocket then falls down more slowly, and shortly before the landing, we deploy our main parachute, which is slowing the rocket much more, so the rocket lands safely. Here you can see the actual parachute ejection. Basically the nose cone, so the front part is as said, shot out the main or the front part can fly up to 2 or 3 meters from that created pressure. And we do want to do that more or less violently. Well, how do we know when to eject the parachute and what actually does the ejection of the parachute? That's what Jonas will tell you more about.
So this is where our electronics actually come in, and of course our code. What does our electronics do? We need to sense our environment. We need to sense the tank level, engine performance, evaluate the flight trajectory by, for example, air pressure, by GPS, by using accelerometers and sensor fusion. Then we need to decide, we need to filter those values, decide which flight mode we are in, if we should deploy the parachutes, if we have even left the ground. We need to detect possible failure states of systems and shut down, and then if there are failure states detected, for example, we need to act. We need to open close valves. We need to ignite the engine. If the launch command was sent, we need to open the parabrakes and release the parachute. Then, of course, we need to communicate with our operators at the ground, give them live data overview, and make sure that we can intervene if something goes wrong, or if there's a software or hardware bug, or the competition says that we can't launch unexpectedly. Also, we store the sensor values in the flash because our downlink budget is not large enough to store all data we would want to evaluate later. So what electronics do we need for that? We do have our flight computer and our sensor. You can see this PCB. This is our flight computer. It is self-designed, as almost all our PCBs are that we use. It has the different sensors for computing the flight trajectory, like a barometer, accelerometer, gyroscope, IMU, GPS. It has everything. It is based around our core board, which is actually a board which you can use for drone flight as well. So it was designed for dual use. Then we have controller boards for controlling our valves and for igniting the engine. These are not shown here, but I have them with me if someone wants to take a look at our PCBs later. We have cameras for PR purposes, and then we need to have a radio link to our ground station, which at the moment is a laptop connected to a LoRa modem. So this is how that looks in the rocket. This is an overview of our rocket. As you can see here, there are many sections. It's very complicated. If you want to find out more about that, you will need to visit us. So what do we need for our radio link? The radio link needs to be high range because we need to ignite the rocket from at least 500 meters away to be safe. It needs to be low power. It needs low packet loss. And the hardware must be affordable. And we can't depend on the 5G infrastructure in the air and on the launch site. And what we have decided on is LoRa, which stands for low long range. It doesn't use just one frequency, but it uses a whole band of frequencies and sends so-called chirps over these frequencies. So you can see here in the charts. And this is used to encode different symbols. Then, of course, we have communication inside the rocket. The rocket is divided into many sections, and the flight computer PCB just can't be long enough. It can't be 3 meters long for it to control everything. So we need to communicate between our boards. For that, we use CAN bus. It's a binary-based protocol that works with differential signals. And it is bus-based, so we don't need cables for every component, but we connect every component to our shared bus. These are the flight phases that Marco explained earlier. You can see schematically how the parabrakes initiate the flip maneuver. The question is now, how do we decide when to deploy the parachute? We could do a if statement like that. I think this is actually present somehow in our code. But to keep track of everything and to validate everything and so on, we have a state machine. It's just a very intuitive way of describing the different states. So this is what our ground station software looks like. It is compatible with all MAVLink devices. We use MAVLink. It's a protocol designed for drones, for drone communication, to communicate with our rocket with a special dialect. So everyone familiar with a MAVLink or drone communication can read our code more easily and understand what we're doing. These are some screenshots of simulations we connected our software to. If you are interested in secure software or Rust code, then I think this could be a very interesting project for you. Who here has programmed in Rust before? That's an unexpectedly large chunk, but I like it. Yeah, we chose Rust mainly because it's interesting, and we wanted. It's nice to program, because in C++ you have to worry about like memory issues, and you have to worry about raw pointers and stuff like that. And the Rust compiler really guides you and enforces that you do your software, that you structure it in a safe way, which can be annoying, and the learning curve is steep. But I believe that we couldn't do such a complicated program if we used another system. We need to be very efficient with our filters, for example, with the implementation of the Kalman filter on a rocket. And we also need to make sure our packets are compressed, because we have a downlink of 1 kilobit per second.
Well, enough about code. So one last big component is missing. To complete the rocket, of course, all the stuff Jonas talked about needs to fit into somewhere. That's where the airframe comes in. It's basically all the things you see from the rocket in the end. Yeah, of course, this influences the rocket itself quite a bit. There's aerodynamic things you have to consider when building the rocket, but as you're studying information technologies, I will gloss over that quite a bit. So just so you know what you're looking at, the lower part, there's the motor section, so all the hardware parts, the valves, the actuators, that's where the oxidizer comes from. We use external pressurization to get a more controlled burning phase, basically. That's where the main electronics sits in, so basically the brain of the rocket. It's the flight computers, but we got more electronics distributed throughout the whole rocket. Of course, there's the parabrake, which we talked about, the chute compartment, and so on. We use carbon fiber for most of the rocket, but there's some sections which need to be radio transparent for the LoRa to properly work. So the electronics compartment where the flight computers sit in is made from glass fiber composites instead. Enough about our old rocket or our current rocket. Our club basically also does some other things than building rockets. We have some more sections which I will quickly introduce just for the sake of completeness. We also have a satellite section, which is currently building a CubeSat, which is planned to launch next year, as far as I know. Soon. We'll see about that. Yeah, the development itself is quite far already. There's only a few tweaks being made, and they hope to introduce the operation phase soon. Then we have the Casima team, which is building rover equipment and also tools for astronauts. It's more prototyping, and I guess playing around, seeing what's possible. They plan to use the Moon Analog Facility in Köln for that. That's a joint group from all the German-speaking rocketry teams around. And of course, there's also some PR stuff and event management, which we do quite a bit. We have regular events that all the club members can participate in. We do film nights every now and then, every few weeks. We go to local pubs also every few weeks. We have a summer party, a Christmas party. Of course, that all needs organization, and we want cool shirts and stickers. So that's all being organized by the PR and event management team. We've talked quite a bit about Rapid itself while talking about the rocket, but here's a quick overview of what sections the team is comprised of. So we are part of the avionics section, so building the PCBs, designing the PCBs, writing the code, basically doing everything intelligent in the rocket. Then we also have the aeroframe section, which is doing the hardware stuff. We have propulsion section, which is doing the engine. We have a payload, which is like what our rocket transports. Yeah, if you want to know anything more specific about that, you are very welcome to come. I've talked a bit about the other project, so I will gloss over that. I think the time is quite far already. Yeah, here you can see maybe, so you know what I've talked about, the Luna facility in Köln, which Kasima already visited once to test their prototypes. Of course, if you join a club like Tutsat, you get the opportunity to join events. You can join, or you can come for EUROC, the rocket, the launch events. If you participate actively, you can visit the Luna facility, for example, which is quite cool, and you don't usually get access to such facilities on your own. EUROC, as said, is the event we have as a goal from the rocketry compartment. It's the biggest rocketry competition in Europe. There's some in the United States as well, but we like to stay localized, also because it's less expensive and you can go there by car. It's quite a big event. Around 50 teams are applying to get into that. Usually the best 25 teams are being accepted. We've been there 3 times so far. We will go this year again. Twice, we have been twice. Not too important. Yeah, so join the team, join the crew for Portugal. It's like 2 weeks having fun and work on the rockets, exchanging with other teams, and yeah, just having a great time, basically. Some history about our club. We've launched quite a few rockets already. We started small with rockets this size. Before that, there was a water rocket series, which I will not go into much further. This was our first solid motor rocket. Here you can see the rocket from the video. That's the one we used, or we built before that, which was basically a smaller version of this. That's our rocket we wanted to fly last year, but will now hopefully fly this year in Portugal. Yeah. Some data about the rocket we plan to fly this year. It's gonna be roughly 45 kilograms. It's not quite clear yet what the exact mass will be, as we're still searching for components and stuff. Okay, I think I will come to an end. Some more insights. I will not talk more specifically about that. the ones I mentioned. Yeah, so we do cool stuff. If you'd like to join, feel free to visit our meetings. It's once a week for Rapid. The other teams also have regular meetings. You can find more information on the link or on our website. If there's any questions, feel free to ask now if there's enough time for that. Otherwise, just come by or write a mail.
Ask us later here.
Yeah. Yeah. Sure. No, that's not wanted by UROC, basically, because you would be able to guide the rocket to probably harm people or do other stuff. It's also quite hard to do the controls, so the rocket is aerodynamically stabilized. Yeah. There's the possibility to do altitude control, which we did. So we were able to use thrusters, cold gas thrusters, to set a specific height, which we reached quite precisely. Some teams use parabrakes, so basically introduce more air friction to control a specific height, but that's all we do from control. Yeah. Okay. If there's nothing else, thanks for listening, and hope to see you somewhere in the meeting.
So, welcome. I thought personally that we were invited to give lightning talks, so 10 to 15 minutes. Somehow the last two talk about an hour or so, so I will try to keep me short or keep the talk short. Also, I'm not from a university group. I'm here to present a little bit of my research. I was asked an hour ago, basically, hey, we have someone skipping. Can you talk about anything you want? So I thought, yeah, sure, let's talk a little bit about my research, and on the way, maybe talk a little bit about AI research in Darmstadt in general. So first, who am I? I'm Jannis. I am a PhD here in Darmstadt. I studied here. I was part of the student council for some years, and now I'm doing reinforcement learning at the group of Christian Kersting, who's also the director of Fashion AI, which is a not a group, but basically a center for research over the state of Hesse, where we, in Darmstadt, but also, for example, in Gießen or in Frankfurt, try to improve our research, talk to each other, and basically build a global hub for AI research, which means we basically bring 2 to 3 new professors into AI every year. I think this year we alone got 2 or 3 new professors here in Darmstadt for this field, and we will grow in every year now. So the goal is to make Darmstadt one of the central spots for AI research in Germany, but also worldwide. That at least is the goal. So what am I researching? So I talked about reinforcement learning a little bit. Today I'm talking about one specific part or one specific project I have, which basically is object-centric reinforcement learning. And the idea is to show you a little bit what this means. And the title is Pixels Are Not Enough. Why is this a title? So I will keep it short, give me 2 minutes. If we think about reinforcement learning, or in general how we do machine learning, we have a neural network, we put an image, in this case the 3, into the network, and the network then looks at parts of the image to make a decision. There are different ways to do this. For example, there is a convolutional neural network, which basically takes an image and splits it by pooling. But in general, the idea is we take an image, we put it into a neural network, and we get a decision. Simple. That's everything you need to know for this presentation. So when we present our research, we can do it in a very boring way, or we talk about games. And I am a huge fan of games, so I present here 2 games which I use in my research, which is the old Atari 2600 games, because everyone knows these games. I think if I ask you now, who of you knows Pong, I would see everyone raising their hands. That's good, because this means I explain my research with Pong, and everyone can understand it better than saying I have this robotic problem here with this arm here grabbing something, which will confuse half of you, including myself. So we go and stay with Pong here. So yeah, basically, as I said, we play Pong by using these neural networks. We take an image of the game or game frame, we put it into a neural network, and this neural network then decides if we want to go down or up or fire, depending on the game, basically make a decision. If we talk about chess, it's the same. We put the chessboard into it, and they say, or the neural network said, we will play this move. The problem is this. We put it into a neural network, the neural network says go down, but if we now try to understand why this neural network wants us to go down, it becomes tricky. These neural networks are often not really explainable or interpretable. We call it off black box magic because we don't really understand the math behind it. We know that these neural networks doing 1,000, 1,000,000, or 1 billion mathematical equations in them, and they use these mathematical equations to come to a decision. But as humans, understanding all these millions of equations is a little bit tricky. And this is a problem. For example, here, we have 2 games, Pong on the left, and one where we decided to hide the enemy. The enemy is there. The game will play as normal. The only thing which we changed is that the enemy now has the color of the background. What do you think will happen? Is the agent still able to play the game? I mean, it's Pong. We just have to go to the ball, hit the ball, and the ball will fly away. Simple. We don't need the enemy for that. Right? The problem is often not as easy as we see it. And we have shown that by hiding the enemy, the agent basically breaks down. And not only a bit. We have shown that the agent learns to play Pong. We don't need the ball. If we hide the ball, the agent plays perfectly, but hiding the enemy is a catastrophe. And this is only a mere example of this. What we showed is that agents often learn these shortcuts. And to be honest, we are humans, we do the same. If we think about mathematicians, and that's what my math prof said in the first semester, we are lazy people. We try to make a lazy decision or an easy decision which solves the problem. If we have the right way and the easy way, we often select the easy way. Agents do the same. However, nobody is talking about that. If the agent has 2 ways to play a game, by either following a small ball, which maybe moves a lot, or the larger enemy paddle, it of course decides to follow the larger enemy paddle because it's easier to follow a large object than a small object, which is merely 1 or 2 pixels. So this is a problem. And we put this into a paper and put it into a conference, and then the reviewer came back and they had said, yeah, actually everyone knows that. That's not new. We have shown that 20 years ago. Why do you bring it up? And we thought, okay, for us researchers, it may be very clear. But if we now look at how these agents are put into our real world, by, for example, driving cars, that's not so clear. There is a funny example for this in, I think in Los Angeles. There are self-driving taxis, and there is a taxi driving in a roundabout, round after round after round after round, because it can't get out anymore. And the person can't get out of the car because it can only get out of the car if the car stands still, which it never does. So these shortcuts are everywhere. But okay, back to the paper. We said, yeah, okay, sure, everyone knows that, but let's try to make it clear. If we change an environment by making it a little bit different or even easier, for example, let's take this example of freeway. The goal is you are the chicken, you have to cross the street. The cars are moving and you have to basically dodge the cars. So what happens if we stop all these cars? Set it into parking mode. Every car is stopping moving, they're standing still on the corners here. Should be simple, or we put it to a human and the human said, yeah, it's just pressing W all the time, it's very boring. But for the agent, all these stopping cars made the agent also fail because he learned, okay, to move over the street, I need moving cars. If there are no cars, I can't move the street, across the street, which is, of course, not what we want to see. However, we put this into a paper, put it into a conference, and they said, yeah, we know that. We don't have to show that. What are you trying to sell here? So we showed that with humans. We put humans in front of these games and showed that all these games are very simplifications, meaning that an agent who have understood the original game should not have any problems playing these simplifications because, as we said, they don't change the task. They just change a small thing, change a color, for example. This shouldn't change the agent. However, we showed that all of our agents, and not only one, but I think we have tested 20 agents from our labs and labs all over the world, are all showing the same problem. They can't play the game if we change a color. And if you now explain to me that for Pong, the background color is important, then I would laugh. Because I think you don't need that. Which brings me to the question how we can solve this problem. Because, okay, we have now identified the problem here, and we have talked about it, but how can we make agents do better? And that's one question I tried to answer in my research, which is object-centric reinforcement learning. Because if we as humans think about a situation, what we often do is we ignore the background. We don't need the background color, we just look at the objects. And we can do something very simple to reinforcement learning. First, what is reinforcement learning? Reinforcement learning is a way to train agents. I often try to explain this by cooking. If you as a human put a hand on a hot oven, you will not do it a second time because you know it hurts. The same here, we basically punish our agent if it goes wrong, and we give them a reward if they learn the correct way. So basically every action gives you a reward. So a candy. Every time you do something right, you get a candy. If not, you did something wrong. And what we now do is we take an image of a game on the left, in this case skiing, and then we use some methods from computer vision or other fields to extract these objects and show that we don't need the background color. We don't need to know that this ski is, or the background of the snow is white. We don't need that the color of the tree is green. We just need these objects, in our case bounding boxes, because it's simple. And we showed that by just using these bounding boxes, we not only improve in performance, but also in robustness. So our agents are more robust against changes in color, for example. Of course, if you remove the color. But also, we showed that by using these masking methods, our agents improved in performing because they don't have to learn what to ignore. We do the job for them. So in some way, we could say this is a form of feature selection or feature extraction. Something we are doing a lot in machine learning, but somehow we have lost this way in deep learning. And nowadays, if you have some experience in AI, you know deep learning is the way. Everyone is talking deep learning, everyone is talking LLMs. And the goal of deep learning is to say, this feature extraction step is nice, but we don't want to do it ourselves, so we let the AI decide. And what this shows is that feature extraction or feature selection, in our case, is still important. And we as researchers or programmers of AI should think about what information we give to AI and what not. So like I said, we'll keep it a little bit shorter, so I will skip some slides. What we can do, here are some works. What we showed here is also that these papers we are presenting are always with some students. I'm a huge fan of incorporating you as students into my research. So if you want to write a thesis, do a practical lab, or want to write a paper because you want to do a PhD in the US or something, come to us. We are quite open to this. This, for example, is a paper we're currently writing, which is a bachelor's thesis from a student from a year ago, and he decided to, and we as a group decided that this work was too good to just be locked into a cupboard in the office, so we tried now to make a paper out of this. The take-home message, what I wanted to show here is that AI has a lot of sides. And if you think that AI is just LLMs, I have to say sorry, because all of my research is not doing LLMs, but, for example, reinforcement learning in old Atari games. And what I wanted to teach you is that at some point, someone will come and say, yeah, this is boring, we already know this, there is nothing new here. And don't listen. These are the old professors trying to do their point. But you are the new generation. You are the new professors or the will-be professors in the future. If you find something interesting, go for it. Because this is what research is doing. There is no, yeah, we know that already, because everything can be changed. And if we, for example, would say, yeah, we always do pixels, so we stay with pixel-based reinforcement learning, we never had gotten the improvements we get with object-centric reinforcement learning. So please, I can give you one thing or what tip or one recommendation for your master's program is, keep asking. Professors are humans. They will make mistakes in their slides, in their talks, in whatever. And you don't ask, they will not see these mistakes. I am a PhD. In my first lecture I gave, I did so many mistakes, to be honest. And thanks to your students, or thanks to my students, I found these mistakes, I corrected them, and I found new interesting ways to research. If you go to a PhD and say, hey, I have this cool idea of a paper or a project, they will certainly say, hey, this is cool, let's talk about it. Because this is what we want. We want students who think. We don't want students who are just here for their masters and then they go away, or they're here because they have to for some ways. We want you to think, to be yourself, to find your interesting ways. And don't accept everything we are talking. Not everything is set in stone. If we would go with this direction, research would be not as funny and that. So yeah. Very short, Darmstadt, as I said, we are huge in doing AI. When I started, we had one professor doing AI, one, and 3 PhDs. This was over 10 years ago. Now we have 150 PhDs only for AI. We have 20 professors doing something with AI or are pure AI professors. We do AI in robotics, AI in deep learning, AI in software development, AI with vision. We do a lot of cognitive science here in Darmstadt with the psychology department. We do basically everything. And like I said, every year 2 or 3 new professors are coming in. So if you have thought about it, maybe there is a field here. We have a lot of, yeah, here are the groups again. I will send these slides to the student council and they will share it with you at the end. For the lectures, we have a lot of lectures which we give every semester. So check out, there is a lot. You can listen to everything, so it's also important for you to make a selection what you find interesting. You don't have to do everything here, please. But check out, if you say you're very interested in texts or images, you may want to check out computer vision or the lab of Professor Schaub-Meyer. If you are more into multimodal stuff, like how to use videos and pictures, then maybe check the lab from Professor Rohrbach. There are practical labs. Like I said, we give a practical lab every second semester, every summer semester. Last year, this was about JAX-based object-centric Atari environments. So basically, the problem is Atari is cool, but it's very slow, it's old, it's running on the CPU, and everything is slow. So what we did was we implemented all the JAX environments new from scratch. We re-implemented them on the GPU in JAX, so they are 1,000 to 10,000 times faster, meaning my research would take 6 hours or 18 days. My longest experiment was 18 days, 5 years ago when I started, and now it is done in 6 minutes, which is a huge relief, to be honest. If you are interested in something like this, check out what labs there are. Yeah, and that's basically everything. So yeah, this is my group. This is the lab of Professor Christian Kersting. We are doing basically everything from reinforcement learning to ethical AI, from continual and lifelong learning. So check it out. We are around 30 PhDs, so one of the larger groups here in Darmstadt. And we are basically very general. And then there are a lot of labs which are more focused. For example, the lab of Jan Peters, who is doing intelligent robotics, so to say. So there's a lot about humanoid robots and how to use AI in them, or with them, basically. So check that out. If you have any questions, feel free to hit me up with an email, or if you find anything on the pages. And I think that's it. I'm not sure if I was the last talk or if there is another talk after this. If not, I will be here 5 more minutes or something, so come by and ask questions. There is an Uni Rally now, sorry. So I will be here, you will get an introduction to the Uni Rally, then you can come by and ask questions before you start your rally.
Yes, so now we're going to have the Uni Rally, but before we do that, first of all, I have to say goodbye to the stream because the Uni Rally is in presence. But for the people who are only online, There's a games on machine evening now, so you can play games online together with your fellow students. So join that. The link and the QR code is shortly, or I think is already in the stream. Yeah, it's going to be shown in the stream in a few seconds. So then you can join online. So bye to the stream. And for the people who are here with us, yeah, we...
you.